Welcome back, everybody. We are at the beginning of week 5. We're going to be spending 2 solid days going over something called functions. Okay. What is it? Tuesday? Yeah, Tuesday we're going to be introducing what a function is. We're going to be writing some really small ones. And then on Thursday, we're going to be kind of applying it. So things might not come together today, but on Thursday it should. All right, today we're just gonna introduce what functions are, and then on Thursday we're gonna jump into some pitfalls and maybe how to put everything together. All right. Before I even jump into this, the lesson and the lab, I figured we'd kind of define what it is. Right, some people might have heard of functions in their math class. It's the pretty much the same thing. In math, you can think of a function as it takes an input and produces some output. So if you've taken an algebra class, you might have seen this function here. The function here is called f. The input is x right here. Right? X could be any number. And then the output is right here, x squared. In programming, it's pretty much the same thing, but there's a lot more we can do. In programming, we'll see that functions will allow us to do something called a black box. Last week, we talked about black boxes, so I'm going to kind of define what those are later. We're going to be able to build Legos. This means that we'll be able to build small things and then put it together in the end. That's what modularity means. It means things are easy to take apart, like Legos. Functions in programming can also improve readability. Right? It'll allow you to understand what's happening more. It'll allow you to kind of fix things a little easier. Okay, so all of this will make sense on Thursday, but these are just kind of motivational things. Okay, I'm gonna show a few pictures, and I want to be showing it again, just so folks see what a function can be visually represented as. Okay, you might remember last week I talked about black boxes. Let me look at the wiki. Black box. Let's see. Last week I put up this picture here, a black box system. The reason why I pulled this picture out was to kind of show how the weather stuff might be working. Like, you might remember in the weather assignment over here, there is a cell that defines something called get weather, and then it takes two things inside these parentheses, latitude and longitude. This was already done for you. This is a function. You can think of it as a black box. So in this case, there will be an input and an output. In terms of the weather one, the input here are the latitude and longitude. And then the output is a dictionary. So you don't really have to know what's going on inside of this. You can treat it like a black box, right? Meaning that as long as you know the inputs and the outputs, you should be good. So we were able to use this black box, right? Right here, we're saying, hey, use it. Give it the inputs, latitude and longitude, and then this whole function will give a number. It's going to return a dictionary, not a number. So the inputs are right here, these numbers, and then the output goes into weather. All right, weather becomes a dictionary. So that's kind of what a black box system is. Right? I'm gonna show a few pictures, and it's gonna come together in probably like half an hour. Okay, don't worry about this code. Just a picture. We'll see this code later. Black boxes can have no input nor output. Right? Notice there's no arrows pointing in and out. Right? It's possible to define a function that just does something. right? You don't have to give it anything. So yeah, that's an example of no parameters nor return value. Okay, you can also have a black box with input but no output. We'll see this in just a bit, but in this case, this is a function that takes a string as an input, and then it's just going to output the string, right? It's not going to return any value, but it will print out something. Okay, cool. And then another one, it's possible to have a black box with no input, right? Basically, you can use it and it'll give you something right away. So this right here, once again, don't worry about the code. We'll go over this code in just a bit. In short, all this function is doing is generating a random number between 0 and 6, and then returning it to whoever called it. This will make sense in a bit. Okay, and then finally, you can have black boxes with inputs and outputs. Right, this is like in the weather project. The weather project over here, right, it does have inputs and outputs. The inputs are here, latitude and longitude, and the output is a return statement, right? This return, so it'll go into this weather variable. Okay, so I'm just kind of showing off a few pictures here. We're gonna revisit this again. I did introduce some terminology that might not make sense yet, like parameters and arguments, and then something called a return value. You can just think of these as inputs and outputs. So I'll make sure to clarify these as we go through today. Okay, so that's kind of what functions are at a high level, right? They allow us to, package things so we can reuse them over and over again. Okay, let's jump into the lesson then. So let me quit this. There's going to be a lesson and a lab. Lesson number 10, and then lab number 10. Okay, there we go. Let's go over the lesson first. Okay, let's start off with a quick small intro. Let me play this first cell. We're planning on using the turtle and having some nice stuff here. Okay, play the first cell. You can think of a function as a group of instructions that has a name. Let's code our first function. This will be called triangle, and then all it's going to do is move the turtle a bit. So the syntax of a function goes like this. It goes like you type in def for define, and then the name of whatever you want to call it. It actually doesn't matter what you call it, but for readability, I'm going to call this function triangle. Okay, and then the next part, function definitions have parentheses. These parentheses indicate the inputs to the function. We're not going to deal with inputs yet. Right? Let's start simple. All right, let's deal with a function that has no inputs nor outputs. All right, so I'm talking about this picture right here, right? Just a black box that does something. Right? You don't have to give it anything, and it doesn't have to give anything back. Okay, so let's write this. So triangle, and then there's a colon here. All right, colon, and then the body of the function. There's some indents, so make sure this is properly indented. You could use 4 spaces or a tab. It's the same thing, as long as it's indented. Right, we'll talk about why in just a bit. All of the indented statements belong inside of the function triangle. For example, let's say there's some instructions like move 70, right, and then turn 120. Right, this is pretty much what a triangle is. You just do this 3 times. All right, let me put some vertical white space here, make it easier to read. Cool. So there is our first function. Let me play this real quick and see what happens. Okay, so I pressed play, and it ran. It didn't do anything though. It actually did do something, by the way. You just don't see it. Right? People might have expected there to be a turtle, but nope. This is called a function definition. It's defining something to exist. Right? It's not using it yet. So this block of code is saying, hey, load into the kernel the process. Right? It's saying we have a function called triangle, and it's going to do this. Right? It's not going to do it yet. Right? If we want to execute the function, you have to call it, right? So, or invoke it, right here. All right. So if I want to execute this function, I'm going to run it in another cell right here, down here. We got to invoke it, meaning just type in the name of the function. But really important, we do need these two parentheses. It's this should make sense in a bit. Basically, these parentheses represent the inputs to the function. In this case, there's no inputs, right? But we do need these parentheses. Otherwise, it's not going to invoke it correctly. All right, so let me put a comment here. This is invoking a function, right? Meaning we're actually going to execute the instructions here. Okay, so let's go ahead and press play here. Okay, there we go. I press play. Let's scroll down a bit. Let me scroll up. Okay, cool. I press play, and we see that it drew a triangle. Right? All it did was, it says, hey, go up here, right? And then execute the body of this. Okay, hope that makes sense so far. The cool thing about functions is they can be easily reused. Right? Reuse is a very good pro here. So if we were to draw more triangles, right, we'd just have to call this function again. All right, so let me move it a bit. Let me move the turtle up like 70 pixels. So let me test it. Okay, cool. So I drew a triangle, the turtle moved up, and let's go ahead and draw another triangle. So I'll invoke it again. Press play. There we go. See how it drew a triangle down here, moved up, drew another triangle. All right, you can go ahead and draw another one if you want. I'm gonna go ahead and let's see, how should I draw this? I want to make a Triforce, like the Legend of Zelda. So let me look at this function. So it moves, turn, move, turn, move, turn. Okay, so that means I need to move the turtle over here. Yeah, I need to move the turtle into this corner and then make it face up. So let me get that. I guess I gotta rotate it first. tu.rotate, turn 120. Let me just see if 120 faces the right way. Okay, there it is. Now let me make it go down 70 pixels. tu.move 70 pixels. And then, okay, cool, there. And then now I just need to make it face north. There's a couple ways you can do that. One way is you can just turn it manually. You can turn it, I think negative 120. It's gonna make it face north. Okay, there we go. Cool, and then from here we can just draw the triangle, right? Because the triangle will do the move set for us, right? See, the triangle does move, turn, move, turn, move, turn. So it should draw a Triforce. All right, there it is. All right, if folks are wondering what a Triforce is, if you ever played Legend of Zelda, this is a game I grew up with on the Game Boy. So yeah, Triforce. This is like a logo. Okay, cool. Hope that makes sense so far. Any questions about this stuff so far? Okay. So yeah, we defined a function and then we invoked it 3 times here. Pretty cool stuff, right? This is an example of a black box with no inputs, no outputs. All right, once again, don't worry about this code. It's going to make sense in a bit. But the triangle function, all it did was draw a triangle. All right, you didn't have to give the function any information, and the function didn't have to give us any information. Okay, hope that makes sense so far. Okay, let's move on to what a skeleton look like. Yeah, this is the general skeleton of a function. We already went over this. Basically define and then some name and then 2 parentheses. It's important to have those parentheses, colon, and then an indented body. Okay, so here we have an example of a kind of a hard-coded function. It's hard-coded because it's always going to print the same info, and there are 2 variables that are hard-coded here. So here, let me modify this cell a bit so people kind of see what's going on here. Okay, let me, I can't modify this cell. I think I pressed the keyboard shortcut on accident. You can edit it. So I'm just gonna click on top right and then make it editable. Okay, cool, I should be able to edit it. I'm planning on just commenting this last line out so people see what's happening. Okay, if I press play here, what do you think is gonna happen? All right, well here, let's read it slowly. This block of code is defining a function, right? It's loading a function into the kernel so we can use it later. And then this next line here is a print statement. So let's go ahead and press play. Okay, I pressed play and it said this is my program. Right, that makes sense because yeah, we have a print statement here. And then if we call the function, right, in this case, it's just my function. That's the name could be whatever you want. Right, you could name it foo as well. Right, you could name it whatever. Okay, but I'm gonna leave it here. Press play, and the point here is to see the order, because some people might think it's going to print hello world first, and then this is my program, right? But that's not the order of execution, right? We defined it, right? It's not being invoked yet, and then we print this is my program, so that's technically the first line, and then we call the function, so then it's gonna go up here and call this print statement, which just has hello world. Are people cool with this so far? Okay, hope that makes sense. So yeah, just the ordering. Or if I were to change the order of these last 2 statements, hopefully people might predict what's gonna happen. All right, it's gonna print hello world first, and then this is my program. All right, so press play. Yeah, there we go. Okay, hope that makes sense. All right, let's move on. Let's talk about the indents and why they're important. The body of a function has indents, right? You can think of it as 4 spaces or a tab. Same thing. In this case, this is a function that has only 2 statements. Right, so this is kind of a pitfall when people write these. Let's go ahead and prove it that these are outside of it. So let me just make another cell here. Plus here. Okay, make another cell. I'm gonna paste this example here, this lineup, and prove that there's only 2 statements inside of this. Okay, so I will press play. All right, let's press play. Boom. Okay, I press play, and you see the print statement. Right, it's only printing these out here. Right, this is outside, still outside. Right, the reason why is because we defined a function with only 2 statements. Right, these are indented, so we defined it, but we never called the function yet. If we want to call the function, right, hopefully people remember, you would just type in the name of the function, and then these 2 parentheses. Right, these represent the inputs. So hopefully you can kind of predict what might happen. So press play, and there we go, right? It prints these 2 lines first, and then it prints these inside the function. All right, does that make sense? The point of this is to show the importance of indents. Okay, so technically it's reading it like this right here. All right, I just added some new white space. All right, any questions about this so far? Okay, cool. And you don't have to worry about this stuff right here above. This is just showing other styles, right? In C++, indents don't really matter, but it's typically there for style to show what belongs in what. I mean, in C++, you don't really need indents, but that's going to lead to kind of ugly code. Python is important with white space, right? The indents do matter in Python. You can actually just miss a space, and then it might mess up, right? So for example, if I were to just backspace, right? I just did backspace once. So let's test this. So press play, and there's an error here. It says unexpected indent right here. It's pretty much saying that these two don't match. So I would make them match with 4 spaces or a tab. Okay, cool. Hope that makes sense. Okay, so we just went over this right here, a black box with no input nor output. It just does something. Let's go ahead and talk about black boxes that take an input. It's not gonna return anything, but it will do something with it. Okay, so here's some terminology here. There's something called an argument. An argument is a synonym for input. For example, here in this function, if we define something called say hello, or I'll just call it greet, just so I can stick with the slide right here. So let me just call this greet. Okay, so I just defined a function called greet. Let's put a argument in here. Okay, the argument is an input, and the name could be anything you want. Right, I'm gonna just name it name. All right, well, once again, this is just a variable that represents an input. Right, it could be anything. It could literally be anything right here. Right, but I'm gonna name it name for readability. Cool. So there is a function that takes an input, and we're gonna do something with this input. All right, let's just greet this name. Right, greet the input. So I could do a print statement. I'm gonna use an F string. This way I can interpolate name into the string. So hello name. All right, let me go ahead and press play. And okay, yeah, see, it didn't do anything. But once again, I'm gonna repeat this a bunch, just because it's a very common pitfall. People might think it's supposed to do something, but it doesn't. Right? It just loads a function in the kernel, and then we can call it here. Right? We can finally execute that. So let's go ahead and try executing it. Right? In the previous functions, we executed just by typing in the name of the function and then 2 parentheses. Right? This isn't going to work here though, because it's going to give us an error. Right? Missing one positional argument, name. This is saying that we incorrectly invoked the function. Right? Our function is expecting an input. Right? In this case, this input is some variable name. Right? So it could be a string. So if I put a string here, right, like Andrew, right, press play, it says hello Andrew. Right? The reason why this works is because this string gets passed into this function here. Right? So Andrew goes into name, and then the print statement will print Andrew. Okay, hope that makes sense. Yeah, does that make sense, everyone? Okay. We can reuse this function over and over again. Like, I could say greet Bob. All right, press play, and there we go. All right, we're doing that, and let's call it again Charlie. All right, that's the cool thing about functions. We can clean up code, and it's gonna possibly look a lot cleaner. Okay. Functions are good for packaging computation and making things a little more general. You see how this function here is general. It can work with any name. Right? We put Charlie here, Bob here, Andrew. A pitfall for functions is to kind of hard code variables. Like let's say over here in the function definition, right? A common pitfall would be to hard code this variable, right? Like some people might put, oh, name is equal to Andrew, right? This is technically hard coding. It's overriding this input here, right? Overriding. So if I were to reload this function back in, right, let me press play. So I'll press play, reload it. And then if I play this cell here, right, what do you think is gonna print? Right, there you go, press play. See how it's printing hello Andrew like 3 times? Right, does that, people kind of see the pitfall here? Right, the pitfall is here, greet Bob. Right, Bob gets assigned to name. Right, it gets thrown up into here, but then it gets overwritten. Right, it gets overwritten to Andrew, so Bob gets forgotten, and then we just print Andrew here. Right, so yeah, people kind of seeing the pitfall. The pitfall is hard coding function arguments inside of the body. So it's a good idea to leave the function general, right? Meaning that we're gonna let the caller handle it. Okay. And just to talk more on some terminology, I just mentioned something called a caller. The caller is defined as something or someone that will call the function for us. So this is the caller, right? The caller is in this cell. This might not make sense yet until later, but this is important terminology because as programs get bigger, functions are usually defined in a different file. So imagine you're working in an industry and you have a bunch of coworkers. Maybe your job is to define some functions that your coworker will use. So in this case, you'd be making tools, right? You're going to be making tools in a different file, and then your coworkers will call those, right? They're going to be using your functions. Okay, cool. I'll talk more on this terminology later. Caller. Okay, let me make sure this still runs. Okay, any questions about this? Okay, this was an example of a black box with input but no output. Technically, there was output, like a display. It displayed a name, but the type of output I'm talking about is called a return value. This will make sense in a bit. A return value is something that you give back to the caller, right? It's information that you're giving back. In this case, we're not really getting any information, meaning we can't store this result into something. Okay, it's gonna make sense in a bit. All right, basically I'm leading up to something called black box with an output. Okay, let's go a little down. Let's still keep talking about these types of black boxes, functions. Right, let's keep talking about inputs only, but no return values. All right, it's possible to make a function that has multiple arguments as well, multiple inputs. So inside of the parentheses, you can do a comma and then put another name there. So let me go ahead and define this function. Let me make another function called name tag. Right, it's really just another greet function. Okay, and 2 parentheses, and then inside of the parentheses, this will represent the inputs. Right, you can call it whatever you want, right? But for ease of readability, we'll call it first name and then last name. Right, don't forget the comma here. Cool, there we go. All this function is going to do is grab the 2 inputs and then just print it out. So let me go ahead and print it out. Hello, my name is, and then this is an F string, so I'm just going to go ahead and put those names here. Okay, there we go. Cool, so I just defined a function with a single print statement. Let me press play. Okay, it didn't print anything yet. Let's go ahead and call it. All right, we're gonna call the function or invoke, right, meaning to execute the instructions underneath it. So the way we do that is by saying name tag, and then these parentheses, and then we're gonna go ahead and give it some values, right? We can give it some values. So you could put something like 2 strings, right? I could put Andrew, and then as a second string, I'll put tech, right? This is going to put these 2 variables into here, right? It's going to assign those 2 values, and then it's going to spit it back out. So there we go, right? Hello, my name is Andrew Tech. And once again, you can reuse this over and over again, right? Like you can call it again with some different names, like Bob Smith, right? And press play, and then yeah, hopefully people are seeing the cool thing about functions now. All right, we can kind of hide this away. I mean, this isn't really hidden. It's right here in plain sight. But as programs get more complex, you're typically hiding away the functions. All right. I do want to repeat some pitfalls that might happen. So once again, a pitfall is to hard code these arguments. All right, so it's usually a bad idea to overwrite them. Like if I were to say first name is equal to Andrew here, and then last name is equal to Tack. Right, this is hard coding. We're actually losing information when we do this. All right, see if I were to run this function, press play again. All right, we lost information because in the Bob Smith, right, Bob Smith does go into here, right? It does, but then these next 2 instructions are overwriting it. so we lost data before even printed out. Okay, I hope that makes sense. So I'm going to remove this. There we go. Any questions about this so far? All right. Cool stuff, right? Okay, let's see what else. There's one thing I kind of skipped over from the very beginning. I'm going to scroll back up to the top real quick. One thing I skipped over was something called a docstring. So here at the top, there's something called a docstring. This is a fancy word of saying comment. A comment is usually for humans to be able to, understand what's happening in the code. But typically functions have a comment that describe what's going on. For example, this triangle, right? A quick comment you can do is just say draws a triangle with turtle. Right? That's really what the function is doing. So yeah, this is called a docstring. This is kind of important, not for humans, but also for tools. Like documentation typically generates the websites based off of comments. For example, if I were to go into look at primary documentation for the strings, all right, so this is going to bring us. So here's a primary documentation, and I'm going to go to string methods here. All right, so let's see, what do we use here? I'm trying to see, we use a couple of these. Anyways, you can just think of these as functions, and the doc strings are right here. All right, see all these? So this website, when it was made, it wasn't a person going into here and manually typing in these paragraphs. Right, it's actually generated from the doc strings. So there's a tool that goes through all the functions, reads the doc strings, and then it can generate a documentation. Right, if you're working in the industry setting, this will help your coworkers understand how to use that tool. Okay, so yeah, that's kind of the importance of this docstring. And you can also see here too, if I add another cell, right? If I use this function called help, right? This is a Python function that just spits out documentation. So if I say, oh, help, I need help on triangle, right? Python will tell us, oh, help on triangle. Here's the documentation, draws a triangle with a turtle. So this is actually not it's pretty short, but you can look at other stuff too, like TU, right? TU, it's gonna give us documentation. So I said, oh, give me help on TU, the turtle. And you see all these, right? These are all doc strings. It's all doc strings inside of another file. And it's kind of telling us how to use these certain functions. Okay, hope that makes sense what a doc string is now. So I'm gonna go ahead and comment my other functions real quick. Let's see. I'm gonna comment this one here, greet. All right, this is one of the later ones we did. So greet, all it does is, you can keep it short, right? Greets a string. Or I'm just gonna say prints a greeting. Okay, there you go. Comment. Okay, and then here's name tag. Let me go ahead and comment this. This is the last one we did. It it generates a greeting with first and last name. Okay, these are just really short doc strings. In the future, we're gonna do more descriptive ones. Like, you'll see this later, but doc strings typically are multi-line. It's typically a multi-line comment where the first sentence represents the purpose. So the purpose here is it prints a greeting. All right, so that's just a short description. And then there's typically some more comments that describe its inputs and outputs. Or for example, the inputs or arguments, right? There are two inputs. So they're typically, the two inputs here are first name, right? And the first name, this is the name of the variable, and go ahead and describe what it does. All right, this is just a string. And then next we have another one, last name, which is another string. And I guess technically to make this more descriptive, a string to greet. Right. So it might seem like I'm being over descriptive, but as functions get more complex, this is pretty necessary, right? You're pretty much, you don't really want other people to look at your code. You want them to kind of understand how to use your code. So this stuff will help them. Okay, doc strings usually contain the inputs and outputs, right? This is the inputs. Typically we would describe its inputs here, outputs as a return, but this function doesn't return anything. We'll talk about returns in a bit. Okay, so yeah, we'll see more on this doc string later, right? If you want to take a sneak peek, you can scroll all the way down and then see some examples, right? Like here's a fully built doc string, right? The purpose, and then the input, and then the output. Okay, we'll practice this in a bit. But anyways, where were we at? Okay, we were here. We were talking about functions that take an input but doesn't return anything, right? It just does something with it. So we can actually generalize our triangle function. Remember up here at the very top? At the very top, we defined a function called triangle, and it's kind of hard-coded to be size 70. Right, it's hard-coded. It's possible to generalize this function and have it work with any size triangle. Right? All we have to do is add an argument, right? Add an input and use that input to control its size. So let me go ahead and copy this. This is at the top, right? At the very top. I'm gonna copy this and then go ahead and generalize it down here. So I'm gonna scroll down. Okay, right here, right below the name tag stuff. So here's our old triangle function. All right, it's let me make sure it works. So let me run this. Okay, I just redefined it. I didn't have to do that, but I ran it anyways. And I'll call triangle. There it is. I'm calling it. Okay, cool. Function works. I'm just making sure. This function is hard coded to be size 70. If we were to generalize it, we'd have to add another argument here. I mean, add one argument that will represent it. So you could call it size. And then this size will go into all of these moves. So paste, right? The moves is what controls the size. Okay, and then now I need to play this. I need to reload this function into the kernel. So there it is. Press play, and then let me try running this. Right, it's gonna give us an error here. And I hope people see why this error exists. Right, triangle is missing one argument, size. Right, this is saying we incorrectly invoked the function. The function is expecting some number. So you could put a number here, right? You could put like 70 here. And then 70 will get passed into size. And then we'll use that 70 for all of these moves. So let's press play. See, there we go. There's a triangle of size 70. Right, and we can control its size. We can just make it 50 right here. Press play, see the smaller triangle. Wait, we can draw more. Let me move it a bit. Let me move the turtle like 50 pixels up and then draw a bigger triangle here. So let me draw a bigger triangle, size 100. All right, people cool with this? So all we did so far was generalize this triangle function. Pretty cool stuff, right? Hopefully people might get an idea on how to maybe simplify your robot cat. The very first assignment, we drew a robot cat. It's over here. Projects, robot cat. All right, this is our very first assignment. It's actually possible to do this assignment using several function calls only. Like let me see how many. Let me see how many shapes there are. So there's 1, 2, 3. There's 3 squares. And then how many triangles are there? 1, 2, 3, 4, 5, 6, 7. 7 triangles. So 3 squares plus 7 triangles. It's possible to draw this robot cat with 10 lines. Assuming that you define some functions somewhere else. So yeah, hopefully people might see that this is actually your next assignment, by the way. I'll talk about it on Thursday. Pretty much the next assignment is to draw robot cat, but use functions instead. Meaning that you can define a triangle function. You can also define a square function. And then in another cell, you can just invoke them. Okay, cool stuff, right? Let me go ahead and update this docstring because we change its input here. I'm gonna stick with the multi-line. Hold on, I can't edit this. That's weird. I feel like I keep pressing some keyboard shortcut that locks this cell. Okay, there we go. Unlocked. Okay, draw a triangle. I was gonna update this docstring into a multi-line comment. So the purpose here is draws a triangle using the turtle. Draws a triangle of specified size using the turtle. Okay, And then typically in a doc string, you want to talk about as inputs and outputs. In this case, we only have inputs, the size argument. So there's one argument. Excuse me. There's one argument. It's the size, and then I'm going to go ahead and describe what this input is. It's an integer number that represents the size of the triangle. This might seem overkill, but hopefully people understand why these doc strings are good. In short, it helps other people use your code. Because imagine if you're writing like a large function and you give it to a friend to use, right? They're not going to want to read through all the code, right? They just want to see the English, right? They want to see the English on how to use the function. Okay. Cool, let's see.
I have a question.
Yeah.
So when we're doing the triangle, when we have to put the size in, I can't get mine to not have an error cell. I didn't see where you put the size in to have it have a size. If that does that make sense?
What error is it? What error?
It's the one that we had before, and I didn't see what you changed it to in order for it to. Did you make a new cell and then you called triangle and then labeled the variables? Is that what I'm seeing down there?
Oh, you know what? I think the previous error was, I think it was this right here. Was it this triangle missing one argument size?
Yeah.
Oh yeah. So all I did right here was add a number into the parentheses. So I put like
Okay.
50 here. The reason why is because our function now needs a number. So yeah, here I'll leave this up for just a bit longer. It's yeah, just I only have these two cells. Cool. If that doesn't fix it, feel free to screen share in a bit. We're gonna have some lab time in like probably 5 minutes, and then I could take a closer look.
Okay, thank you.
Mm-hmm. Cool. Yeah. Let's move down. Let's do one more thing and then move on to the lab. Okay. Cool. Final thing. Let's see. We are still talking about black boxes with inputs. So let's do one more. We can write functions to generate websites for us. Let's keep it simple for now. I'm going to go ahead and import this library, which is going to let us render HTML. And then I'll go ahead and define a function. I'll call it HTML name tag. The point of this function will be to display HTML. And let's keep it simple for now. I'm just gonna put one argument here called name. But basically the goal here is to display a header, right? If you were here last week, a header is like a large title. So you can kind of imagine that I'm creating like a string here, right? Inside of this function, I'll call it my HTML. Right, you can call it whatever. I'm gonna set this equal to a multi-line f string. Now, this is stuff from last week. So I'm creating a string, and then I'm gonna display it later. So in this case, I'm just gonna use something called a h tag. Right, h tag is short for heading, which is a fancy word of saying title, right? Large title. And the reason why I'm using an f string is so I can interpolate this variable name into this string. So in here, I'm just gonna say, hello, I am name, right? But name is a variable, so I'm using the curly braces. Okay, cool. So this line, it generates HTML. Here, let me put on multiple lines to make it easier to read. because HTML is typically formatted like this right here, right? This way we can see the nesting. Okay, so there we go. We created an HTML string, and now I'm going to go ahead and display it. So, well, first you gotta convert it to an HTML object. Okay, and once again, it's very important that these are inside of the function. So make sure it's indented properly. And then go ahead and display that object. Okay, cool. Let's test it. So I'll press play. All right, this is technically not testing it. We're not testing the function. All we did was load it in. Right? The way we test the function is by actually invoking it. So I just made another cell here, bottom here, right, just to kind of test it out. So we could test it with calling HTML name tag. And then currently our function only takes one input. Right? The input here is some name. So I'm gonna put it a string here and just say Andrew. All right, so Andrew, press play, and there it is. I gotta scroll up a bit. Okay, there it is. Yeah, hello, I'm Andrew. All right, and you can do this over and over again, right? You could say, copy that, say Bob, and then press play, and there you go, right? We have two headers, two big titles. All right, let me add one more argument to this HTML name tag, like maybe some argument that will allow us to change the style. So, you know, one style we can change in HTML is a color. And that's typically changed in the opening tag. So this is the opening tag right here, this H1. If we want to change the color, hold up, let me first go into the function parentheses and add in something called color. So there we go. We can use this variable and interpolate it into this opening tag. So we could say style is equal to, and then some string, and then color, and then finally the actual value of what the color is. So here I'm going to interpolate the color here. All right, this is HTML stuff. It's not Python, but now let's test it. So I'll go ahead and press play. Okay, so I loaded this function in, and then let me test this over here. All right, let me press play here, and it's going to give us an error. All right, so did our function break? No, it didn't break. It's just that our function is expecting one more argument, meaning that the way we invoked it is incorrect. Our function now expects two arguments. Right? The second one is a color. So I could put like red here and then green here in our function invocations, and then press play, and there you go, right? It should print it right now. All right, people cool with this? All right, I'm gonna put a doc string in here just to make it, just to give it a good comment. Displays a header greeting, and then go ahead and describe as inputs. So the arguments, there's two of them. There's one called the name and one called the color. And let me go ahead and describe it. String, the string to greet, and then this is the color, which is a string. It's another string. A string to style. It's a string to style HTML. Okay, cool. Let me press play, and there we go. We should be good now. All right, so let's summarize what we did so far, and then we'll move on to the lab. And then after that, we'll jump into the rest of this lesson. We haven't talked about return values yet, but we'll talk about it later. All we did so far was talk about functions that have no input nor output, and then we inserted an input. So we just did two different types so far. Let's go move on to the lab. If anything, there's only like two questions that we can do right here. So lab 10. There's a chance that the first cell in your lab 10 might be weird. Just make sure it looks like this, and you should be fine. Yeah, just make sure it doesn't look like it's on one line here. So yeah, make sure there's two separate statements. And then go ahead and run this first cell. If anything, we have enough to get the first couple down. Part 1, number 1, and then, oh, hold up, I need to reset this because I worked on this right before class. So let me reset this. Okay, we have enough to get 1 and 2 done. All right, pretty much write foo and then write do some. But we don't have, we probably don't know how to do number 3 yet. If you know how to do it, go right ahead. But we haven't talked about returns yet. So yeah, just 2 of them. It's pretty much asking you to first define a function, and then in the next cell invoke it. All right, that's pretty much what it's asking you to do. All right, and for number 2 is the same thing. All right, define a function, and then go ahead and invoke it down here. Okay. Oops, I have part of the answer here. Okay. Let's spend like 10 minutes, 10 or 15 minutes on the first 2. I'm gonna put a timer here. And then for folks who had individual questions, feel free to let me know. I'm gonna pause the recording. I'm gonna pause the recording right now. And yeah, if you're on the recording, please try it out yourself. It's I know I keep saying this, but I know some folks just kind of wait to see the answer and then just type it out. But you're not getting much out of the class if you just kind of copy down the answer. So yeah, at least try it out and run into some errors and kind of see how to problem solve through it. Okay, I'll be back in 15. Pause. All right, we are back from intermission. All right, thank you all for the folks who attempted it. I realized that the instructions might be a little hard to see what's going on. Like people might be wondering, oh, how do I get this started? So yeah, it's a lot of the exam questions will look like this, by the way. It's gonna look like, hey, write a function that does something. So yeah, this is pretty much the format of the midterm and the final. You'll get used to it in a bit. If anything, let's take it slow. So there are 2 cells here. The first cell is used for defining the function, and then the next cell is used for invoking it. So as for defining it, right, let's see what it says. So write a function called foo. Okay, so right here, you should be able to define something called foo. All right, so I'm gonna go ahead and do it here, right? Define a function called foo. Okay, and it is going to take 1 argument called bar. You can call it whatever you want, but this one wants it to be called bar. So 2 parentheses here, and then the input or argument here is called bar. All right, and then finally, don't forget this colon here. All right, this is the syntax of a Python function. You could look back at the lesson. This is arguably one of the most important lessons. So I don't expect folks to get it right away. But after a couple more weeks of practice, it should make a little more sense. Yeah, so this is what the syntax of a Python function looks like. Cool. So here we go. Okay, so we just did this part right here. Write a function called foo, argument bar. Now all we need to do is access that variable and just print it. All right, so all the function needs to do is print the contents of bar. Okay, so right away here, you can just go ahead and print it, right? Bar, print, bar. That should be it. Okay, let me go ahead and test it. So I'll press play. There it is. Oh no, I didn't test it. My bad. I was just loading the function into the kernel. But now we can test it down here. by calling the function. All right, so we could call it by the name of the function, foo, and then this function does take an input. All right, so it's the input could be anything. You could just print like hello. Right, you can print anything you want because whatever you put in these parentheses is going to be assigned into here, bar, and then it's just going to print it out. So I'll press play here, and okay, cool. It looks like we did it. All right, it looks like our function is printing the contents. So let me run feedback here. Oh, the feedback says cell. Okay, I guess I forgot to run the very first cell. So let me go to the top and run it. Okay, run this very first cell. And then I should be able to test it now. Okay, cool. I got an error, or not an error. It's kind of like a warning. Foo should have a docstring. It might seem like it's being picky. Docstrings are necessary when functions get more complex. So I'm gonna go ahead and add a docstring to this function. The docstring is really just going to repeat all of this stuff out here, right? These bullet points is telling us the name of the function, the inputs and outputs. So you can just repeat those out. All right, I'll talk about the purpose first. The purpose of this function is print contents, print specified contents. And then the inputs here, right? There's only one input. It's called bar, which is the content to print. And we don't have any output or return value. Right, we'll talk about return values later. Okay, so let's test it, and yeah, all tests passed. So this seems like a really trivial function. It is. It's really just a wrapper for the print function, right? That's all it really is. It might seem really annoying, but on the exam, it's really easy to grade functions. So you might get a lot of questions that will ask you to do something very small. But yeah, the reason is because functions are easy to test. It's in software engineering, there's something called unit tests. So unit tests in software engineering. I'll Google it. So unit testing is usually defined as kind of just testing small pieces of your code. So if you're writing functions, then it's really easy to grade those functions. I can pretty much write some sort of auto grader that will go through all the functions and check if it's doing the right thing. Okay, so yeah, just number one. Number two right here. Let's do one more. This one, write a function called doSum. Okay, cool. So yeah, right away should be able to define something called doSum. Okay, and let me just set it up. I'll just get the parentheses and the colon here. Okay, and then takes two arguments. Okay, we're gonna have two inputs now, A and B. So right away you should be able to go A comma B. Okay, the function should print the sum of its arguments, meaning that the body of the function will access these numbers and just print it. So you could do this in one line, but I'm gonna go ahead and do it in 2 lines just to be a little more readable. All right, this function is going to calculate the sum of these. So you could make a variable called result. All right, you don't have to. I'm gonna make a variable called result and set it equal to A plus B. All right, and then the next line, I'm just gonna go ahead and print. So I'll go ahead and print the result here. Print result. Okay, so let's go ahead and let's test it. Okay, so I loaded the function, and then down here I'll invoke it. So do sum, and we need to give it 2 arguments, right? 2 inputs. So I'll try 2 and then 4. Right, it should print 6. Cool, it printed 6. Right, that makes sense. Let me keep testing. Let me just make sure it's doing the right thing. So let's try 3 and then 5. Should print 8. Okay, perfect. Cool, so we tested it. Let me ask for feedback. And oh, I forgot the doc string again. Okay, let me put a doc string here. Okay, the purpose of it is to calculate and print the sum of 2 arguments. All right, there are 2 inputs here. There's A, which is a float. Float is a fancy word of saying it could be a decimal. And then B is another float. I guess I could be more descriptive. A float to add, another float to add. Okay, cool. And then all tests pass. Perfect. Cool, so all this function does, right? Once again, it does seem trivial, but all it's really doing is printing the result, right? The A plus B. It's not really necessary to write a function for this, but on Thursday, we'll kind of see why functions are more useful. This is just a really small one. Okay, so that's all we can do for now. Just 1 and 2. Right, number 3 is asking to do a return value. We haven't talked about that yet, but yeah, let's talk about it. So we got all the way in the lesson, all the way down to where return values. All right, this is the part where we're going to talk about these types of black boxes, functions that produce an output, right? And then later on, we're going to talk about functions that do both, right? Take an input, do something with the input, and then give an output, right? You can think of an output as returning a value to the caller. It'll give information to whoever is using the function. Okay, but let's first talk about black boxes with no input, but it's going to return something. So the simplest example here is you can imagine a function that just returns a number. Right? In this case, let's say I were to define a function called a random number. Right? No inputs, no arguments here. And then let me just make it a return. I'll hard code it to return 4, right? Just for demonstration purposes. Okay. So let me go ahead and press play. So there you go. I loaded the function. Let me add another cell. Right? You don't have to add another cell. You can actually call it in the same one. But I'm gonna keep them separate. So in another cell, I'm gonna let me zoom in a bit. Okay, that should be good. I'm gonna invoke the function. So random number is technically not random because it's giving us 4. But yeah, this function is actually going to evaluate to something. Right? It's going to evaluate to 4. Right? And the reason why it evaluates to 4 is because, yeah, it just returns 4. This is different from printing. So I can capture this return value, right? Meaning I can set it equal to something, right? Like let's say I were to capture it into some variable named generated number, right? You can call it whatever. And let me run this. So generated number captures the output from random number, right? It captures the return value, meaning we can perform things on it, like print generated number. Right, we can go ahead and print it. Right, we can do a lot of things with it, like math. You can do so much. Let's see. This is different from printing inside of here, though. Like, if I were to go in this function and not return 4, right? So let me not return 4 and just print it here instead. All right, this is a little different. Let's see why. So I'll press play here. Okay, it reloaded the function in, and let me test it again. So I'll press play, and there we go. Right? See how it says it prints 4, and then it prints nothing here. Right? Earlier it was printing 4, but now it says none. Right? The reason why is because there are 2 print statements. The first print statement happens here. Right? By the way, this first line, the right side is evaluated first. So we go into this function called random number, and it's going to print 4, right? But then when we exit the function, nothing gets assigned to generated number, right? So generated number is technically nothing because it never captured a value. We never returned value to the caller. Right? So this is the caller right here, right? The caller is the person or something that invokes the function. Okay, hope that makes sense. So yeah, it's technically nothing. And if you wanted to return something like return 42 here, right? This function will finally return 42. So press play here, right? See, it prints 4, and then random number, it returns a number, right? It returns 42 into this variable, and we're printing it. So yeah, I hope that kind of makes sense. But basically, when we return a value, it'll allow the caller to kind of use it. Okay, let's make this a little more practical. This is technically not a random number. It's kind of arbitrarily chosen. You don't have to know this, but there's a library called random, and the random library contains some class functions that we can use. Right, we'll talk about class functions in a bit, but basically class functions allow you to do something like dot, right? So I'm using the class and dot rand int for random integer. And let me test this. I'm not sure if this is gonna work. I forgot how to use this function. So let me just see what happens here. Okay, cool. I'm incorrectly using this function. If you're curious what happened, we've seen this type of error before. The function is missing 2 arguments. Basically, I didn't put in some numbers here. And yeah, you can look at the documentation for it if you want. Like if you look at a random Python and look at the primary documentation here, and then look at the rand int. Right, this is the function I'm attempting to use. This is the doc string. It's telling me I need to put A and B. So that represents the lower bound and the upper bound. Okay, let me go ahead and put those in. So for now, I'm just gonna hard code some random numbers, like let's say I want to generate a random number from 1 to 6. Right, this library is gonna generate something from 1 to 6. So I could press play here, and yeah, there we go. Right, see, it printed 2. That's a random number. Let me keep running the cell again. So I'm just gonna press Control Enter just to run it. And yeah, see 1. I'll keep running it. See, I'm running it over and over again. It's a random number between 1 and 6. Okay, so technically a better name for this function would be to maybe roll dice. All right, so I'll probably call this roll dice, meaning I'd have to change these function invocations too. All right, this is roll dice. All right, so let me press play here. There we go. Right, we're rolling dice. Hey, this is useful. You can probably write your own gambling game with this now. Actually, no, probably not. Probably not. We'd have to cover something called if statements, right? Because a lot of those gambling games is like, oh, if you roll this, then you get this, right? If this, then that. So yeah, we'll talk about if statements later. All right. People cool with this so far? So we just talked about this right here. Right. It's possible to take it a step further and make the function more general. Right. Oh, this meant to be 1. It's possible to, some dice aren't 6-sided. For folks who might have seen different types of dice, there's 10-sided dice, there's 20-sided dice. This function is technically hard coded for 6 sides. So if you do want to take it a step further, you could generalize the function by adding an argument here, right? Like maybe an argument that represents how many sides are on the dice. For example, let's say you were to use a 20-sided dice, right? Like I'm talking about this right here, D20. Right, this is like a 20-sided dice. Is there such thing? Yeah, I guess there is such thing as 20-sided dice. So you can imagine something like this. And we're going to add in another argument, right? It's probably appropriate to call it something like number of sides. So you can call it whatever you want. But this number represents the upper bound for this class function. So we can go ahead and put that upper bound into this num sides, right? And now the function is more general. So I'm gonna test it here, right? I'm gonna get an error here, by the way, if I test it. Hopefully people can predict what the error is. So I'll press play. Right, the error is saying, oh, I'm incorrectly invoking this function. Right, that's because I just added another argument. So now when we call it, we have to add some sort of number here. So I'm just gonna put in like 20, right? This means I'm gonna roll a 20-sided dice. And let's go ahead and press play. So play, and there you go, right? It generated 19. Let's test it again. Again. All right, people cool with this? I'm just pressing Control Enter. Okay. All right. So yeah, we upgraded the function. It's more general. Right? It's not hard coded for 6 sides anymore. We ended up doing this right here. We ended up writing a function, takes input, does something with it, and then returns a value to the caller. Right, so then the caller can do whatever they want with that number. Okay, hope that makes sense about return values now. And you could have multiple lines for this. Right, I'm gonna put this on multiple lines. I'm just gonna declare a result and then return the result. It's the same thing. It's the same thing. Okay. Cool. Any questions about this so far? All right. So we were talking about returns. The order does matter. It's possible to do something called early termination, meaning that the function will stop when it sees a return. So in this case, it's not really returning anything. It's actually going to quit the function. It's possible to, here, let me just write this, early return. Right, all this function is going to do is do a print statement here, and then you can return anything. You can even return a number, right? You can return like 1, right? It doesn't matter. If you don't specify a value, it's going to return nothing, right? It's technically going to return none, like this. So you could return nothing and then print not this. Right? The point of this is to show something called an early termination. So I'm gonna make another cell here and then invoke the function early return. Cool. There's no inputs to this function, so these parentheses are empty. And let's go and run it and see how it prints this very first line. And then we end up returning from the function. Right? We return, so then this feature doesn't happen. Right? It might not seem like there's a use for this yet, but there is a use. In the future, we'll talk about decisions, like if statements. Basically, programs can branch off into different scenarios. Right? Like maybe a scenario is if something happens, then quit the function early. Right? If that thing didn't happen, then keep carrying on. So yeah, you'll see a use case for this later. Early termination. Okay, and technically this is returning nothing. There's kind of an invisible none here, a none literal. Right, that's it's technically returning nothing. So it's the same thing, right? Meaning if I were to try to capture his return value, like let me say value is equal to early return, right? Basically, I'm saying run the function and capture the return value. Right, so I'll capture the return value into that variable, and let me just print it. Value is, and then let me print out value here. I guess I'll do it in the f string actually. So f string value. Okay, yeah, we see a value is nothing. All right, there's kind of an invisible none here. You could put some random number if you want, like you can imagine it's like an error code, right? You can return like 42, and then let me reload this function. And yeah, see, value is 42. All right, just okay. Any questions about this so far? Okay. Let's see. Here we see they talk about the debugger. You don't have to worry about the debugger yet. This is just another fancy tool in Jupyter Notebook. This tool is a little more complicated to use. It might be more helpful if we not use this yet. It might be more useful later on when we do loops. But for now, you should be able to kind of debug manually, meaning trace through the code and see what's happening. Okay. Let's see. It's possible to return multiple values as well. So we've seen just return one value, like over here, the roll dice. It's only returning one value. But we can, oh, you know what? I forgot to put a docstring here. It's kind of important. So let me put a docstring in this roll dice. Generates a random number with an arbitrary dice. With not arbitrary, more like a specified dice. Excuse me. So yeah, this function generates a random number with a specified dice shape. There's an argument. Oh, there's only one argument. It's a num sides, which is an integer. It's an integer that represents how many sides on the dice. Let's see. I forget the proper dice or die. I forget. Okay, and then there is an output. So typically this is represented by the returns. Right? It returns the generated number. Right, this is a fully specified docstring. The purpose, the inputs, and the output. Okay. Cool, just taking a little docstring. Anyways, we were talking about multiple return values. So yeah, it's possible to return multiple things too. It might not seem like a use case yet, but there's a use case. Pretty much if you want to write a function that does a bunch of things and then gives back a bunch of information to the caller, right? It might be useful to return multiple things. So in this case, this is just an example of returning 3 strings to the caller. Right? If we were to go ahead and define this function, right, and all this function does is return 3 comma separated things. Right? It could be anything you want. It could be a 1, 2, 2, 3. All right, this is just hard coded to return these 3 strings. So if I were to invoke the function, right, this is going to evaluate to 3 separate strings. right? And right here, right, evaluates. We could capture it. Technically, this function does have an output, so we could capture it into some variables, right? Like you could say, you can just create like 3 random variables and just, it doesn't matter what the name is. I'll call it foo, bar, and baz. All right, this is like saying x, y, z. I just chose some random variable names. All right, so then press play. Right, it doesn't show anything, but these 3 variables do have a value. So if you were to print it, print foo and print baz, right, it's gonna print those 3 things. All right, let me think of a good use case for this, because this seems not useful. Let me think of a good use case. Let me think real quick. Let's see. I guess a good use case for this, it's not really in the class, but if you took like an algebra class, you might have remembered of something called the quadratic equation. The quadratic equation is some equation that can return 2 numbers. So once again, you don't have to know this. That this is, I don't even think this is a prereq for the class. But there's a quadratic formula. Pretty much given some equation, there's typically 2 answers, right? If you're solving for x here, one answer is the plus version, right? Negative b plus this, and then another version is the minus it. So let me pull up an example, like right here, right? Right here, they're actually solving an equation, and there ends up being 2 results for x. So yeah, a use case is returning 2 values, right? So the caller can do something with those numbers. Right, that's yeah, you could do some pretty cool stuff with this. Okay. Cool. What's another use case that's not mathy? I guess another use case is maybe let me think. Yeah, here, I'm just gonna let people get creative and think of use cases. I'm in math mode right now. Okay, let's see what else. On the exam, we have 2 exams in this class, a midterm and a final. The midterm is actually, I think, in a couple weeks. I'm not sure. Let me check when the midterm is. One, two, three. Midterm is in 3 weeks. So in 3 weeks, you'll see a bunch of problems where you'll be asked to write functions that do stuff. And a lot of these functions will be very small. Like they're really going to be like 1 or 2 lines. But it's very important to be able to write functions because in the life of a programmer, you're typically trying to write a program, but have certain pieces be reused. Right? In programming, typically a lot of things are reused, and improve modularity, meaning that you're building Legos, and then you can put the Legos together later. And yeah, readability, right? If you write functions, your code will look a lot more readable. So yeah, that's just to motivate it. It's also for grading, right? Well, when I'm grading it, I'm really just running your function and then seeing if it gives the right result. And yeah, I have a program that can grade programs, so it's pretty important to be able to write functions to spec. So the example problems you'll see on the exam, we'll go over a lot of these in a couple of weeks. But typically, the most important parts is the name of the function. Right? You got to get the name right because that's how I call the function. To call means that I'm gonna invoke the function, and if it doesn't exist, it's not going to be graded. The function arguments, these are the inputs, and then the outputs. All right, all of these are pretty much in the doc string. So here, let's do an example problem. Let's see. Here's an example. You might see this. You might see a variation of this on the exam. This is pretty much asking us to wrap a power operator. Write a function called power of that takes 2 arguments. So here, let's actually start it. Right away, we should be able to define a function called power of. So let me go down here and define it. All right, so define a function called power of. Okay, there we go. We have the function set up. Let me see what else is asking for. Okay, it takes 2 arguments, sig and power. I forgot what sig. Oh, sig stands for significant. All right, so sig right here, and then power. All right, there we go. We have the function kind of set up. If anything, it might be useful to also write the doc string. This way you know the purpose of the function. All right, the purpose of the function is just to calculate sig to the power. All right, so let me quickly put in the doc string. Calculates sig to the power. That's pretty much what it's doing. There's 2 inputs. One is sig. This is a number. It's specifically a float, right? Meaning that it could be a decimal. So sig is a float number, and then power is another float number, I think. Yeah, another float. Okay, and then finally the return. Right, there is an output to this function, and it's gonna returns the result. Returns sig to the power. Yeah, that's really what it's doing. Okay, so real quick, I'm gonna set up a skeleton of this function. Right, this function is still incomplete. It might be useful to. I'm gonna return a dummy number for now. All right, yeah, you'll see why. The reason why I'm returning a dummy number is so I can kind of make sure the function is syntactically correct. Right, syntactically means I don't have any small typos in here. So let me see. Okay, so I just loaded it. I just loaded the function. Let me go ahead and try to invoke the function. So I'll insert another cell. All right, insert a cell here. This is meant to invoke it. So I'll go ahead and call power of, and then it's gonna take 2 inputs, right? 2 number inputs. So the first one is some number, next one is a number. So if I did like 2 to the 3rd power, it should evaluate to 8, right? Because 2 to the 3rd power is 8, but currently is returning 0. Right. The reason why I did this is to catch errors earlier on. Right. Like if I were to have a typo here, then we'd be able to catch it. So yeah, this is the skeleton of a function. This is pretty much the bare minimal you need for minimal credit on any of these sorts of problems. If anything, we just have to actually implement the function now. Right, this function is hard-coded to always return 0, like 2 to the 4th power. Right, this should be 16, but it's always going to print 0. So you could look into it. There's something called a power operator. Right, you could Google this. The Python power operator uses 2 multiplication signs. So let me Google this here. Python power operator. Okay, it looks like the AI here is right. The power operator here uses 2 asterisks, some number to some number. Right, that's going to give you the power. So you could do that. Right, you could go ahead and say sig to the power. All right, this is going to give you the right number. So press play here, and 16. All right, 2 to the 4 is 16. Let's try 2 to the 3 power. All right, 2 to the 3 power should be 8. And cool, yeah, it looks good. Let me go 4 to the 2 power. Right, 4 squared. It should be 16. And yeah, there we go, 16. All right, I'm just testing the function over and over again. And this does return a value, so you could capture it. You don't have to, right? You could say like answer or something. Answer is equal to that, and then print it. All right. The reason why it might be useful to do this is because typically when you're calling functions, you might want to store the result. All right, so in this case, I'm storing the result and I'm gonna print it later. All right, but there's a chance you might want to do something with that result, like in between. Okay, hope that makes sense so far. Okay, I'm gonna modify this function a bit just to make it a little more readable. You can do this in 2 lines or 1. You could store it into result variable and then just go ahead and return it. All right, it's the same thing. Basically, result becomes some number. We return result. So then this function invocation becomes the result that we got. And then that result gets stored into here. Okay, cool. So yeah, that is an example of a problem you might see on the exam. Okay, what else? Let's see, I'm gonna jump into this stuff next on Thursday. I know that this lesson is kind of dense, but you actually should have enough to finish the lab now. So yeah, I'll cover this stuff later. The designing with functions, and then something called scopes. This is important stuff. I'll talk about this on Thursday. But yeah, you should have enough to get the rest of the lab done actually. So over here in the lab, we left off at number 3. So yeah, go ahead and give these a try. Number 3. Looks like I named these. I misnumbered them. 6, you should be able to do this as well. And then part 2 as well. Right, part 2 is asking to write a triangle function and then call it down here. Oh, we already did this. But if you could make it, if you could rotate it a bit and make it look like this, it'd be nice. Okay, yeah, so go ahead and give those a shot. And on Thursday, I will jump into ways on doing these. But please try it out yourself first. Okay. I think we're going to end class here. So yeah, just to kind of summarize what we did so far. We introduced functions. It might not come together yet. Thursday, it might. It might. If it doesn't, next week it should. But basically, we're just writing small snippets. We're writing really small Legos. But you'll see the bigger picture later when we actually put the Legos together. So that's going to be sometime soon. Okay, here, let's summarize. So Thursday, Tuesday, we talked about functions. Thursday, we'll talk about functions again. There's another assignment that's released. It's called Robot Cat. So it's the same thing. The same thing as the first assignment. It's just going to involve functions. And it'll clean up the code a lot more. So I'll jump into some sneak peeks on this on Thursday. And then, yeah, next week we'll talk about interactive programs. This is a way of making functions fancier. And then week 7, we'll do some practice to get folks ready for the midterm. But yeah, I do want to stress that this week, number 5, this is probably the part where it's easy to fall behind. This is mainly because functions is pretty dense stuff. Right? There's a lot to learn with functions. There's also a lot that can go wrong. So I'm hoping to address all of that by Thursday. Okay, thank you all for coming. We're gonna end 5 minutes early today. Have a great day, folks.